Hey everybody, this is Mr. Edwards. We're going to be going over the notes for points, lines, and planes, the vocab. So we're going to be doing that right now. So for those of you who are following along, I have a pre-printed copy of the PDF, but if you were writing this on a notebook, you're just going to want to make the columns and do what you got to do. Okay, so anyway, the first term is going to be point. What is a point? A point is a location. Okay? It really doesn't have any dimensions, has no length or width or thickness or anything like that. And a point is represented by a dot. Okay? We're going to pick a letter to label it. We're going to use R. And points are typically labeled with uppercase letters. Okay, so point R. And the notation is usually just this, it's just R. Right? That's our example. And they might name it point R. Okay? Let me zoom in here just a little bit so you can see a little better. That's a little better. Okay. You can see my great handwriting. Not so much. Okay. So, yeah, that's point. Then we have line. Okay. So what is a line? A line is made up of points and has no thickness or width. Okay. So, oops, I messed up location. So made up of points. Has no thickness or width. And it's also actually it's made of infinite points, which is interesting. A line has infinite number of points on it, but yet it has no thickness or width. Now a line is going to be extending in two directions infinitely, and it's also it's defined by 2 points that lay upon it. Okay, so we're going to call this V and X. Okay. Those are 2 points on it. Now, if we want to label that, we would call it line VX. And we're going to use, oh, why is it not focusing? There we go. It's a little better. Let's fix this camera a little bit. Okay. And we're going to put this little symbol here. Now, that notation indicates, with the two arrows, arrow on either side, that indicates that it is a line. Okay, that's going to be important as we get to some of the other things we're going to be working with. Okay? So this would be line VX. You could also call it line XV. It doesn't matter. As long as the 2 points are on the same line, you can define it that way. Okay? Okay, plane. A plane is a flat surface made up of points. Okay? So it is a flat surface made up of points. Okay, and typically it's drawn as a parallelogram. It's usually the way it's drawn. And oh, it's a crappy parallelogram. Oh well. It's also labeled by, it's known as defined rather by 3 points, and these 3 points cannot be collinear. Collinear means being on the same line, which we'll get to in a bit. So we'll pick 3 points. We'll say V, L, and D. So we could call this plane VLD. And the order doesn't matter. You'll notice that these 3 points would not be collinear. There's no line that would be able to connect all 3. You can also label a plane with a large italicized letter, which is not a point, which can be confusing. So let's call this plane R. And you'll notice I put this big, let me zoom in here so you can see it better. It's this big old italicized R, okay? And it's in the corner, and sometimes you see a plane labeled that way as well. So there's 2 ways of doing it. You can label it with 3 points that are non-collinear, or you can label it as the large italicized letter in the corner, which is not a point. So, yeah, it's kind of a little weird. And like I said, you call it plane VLD, or plane big old weird looking R. Okay. Okay. So what we got left? We got space. Okay? So space is a boundless, 3-dimensional boundless 3-dimensional set of all points. Basically, the idea is that everything exists within space. Space is where everything exists within, and there's no diagram for it, and there's no notation for it. That's just kind of a concept. A line segment, think of it as like a piece of a line. So it's a set of points that exist between two endpoints. So I don't know what the actual technical definition of it is. Yeah, it's basically a line segment can be measured by its two endpoints. Okay, there's really no easy way of thinking about it. Think of it as like a piece of a line. So for example, this was a line. A line segment would be Vx, just the line segment where this is the beginning, this is the end, or this is the beginning, this is the end, depending on where you start. But those are the two endpoints. So set of points defined by its two endpoints. Okay? And it's going to look like this. Endpoint here, endpoint here. We're going to go with VB. Okay? And you could label it. You could label it VB or BV. Doesn't matter. Now above it, this is where it's going to get a little interesting here. I'll zoom in a little bit. It's not going to have the arrows. It's just going to have a little, like a dash above it. Okay? So that is how it is labeled. Okay? A ray. A ray is similar to a line, and it's similar to a line segment in that it has a single endpoint, and then it extends infinitely in another direction. So here we go. So it's going to be this. Ooh. So has a set of points with an endpoint. Why did I put n as a d? Okay, an endpoint, and extends infinitely in one direction. Okay, what does that look like? Think of it as like a laser, right? If you have like a laser pointer, it has an endpoint, it goes infinitely in another direction. So we're going to have an endpoint here, and it's going to go, let's say, that direction. You need another point, though, along that array. So we're going to call this GX. So it's ray GX. Now this is where it gets interesting here with the notation. You cannot be indiscriminate in how you draw the picture above it, or the symbol above it. So the letters, yeah, you can reverse it just like the line, segment, and the line. But you have to be careful here. So let me zoom here just a little bit. Okay, a little too far in here. Okay. So G is the endpoint, right? So that's where the ray originates, okay? And the arrow is going to go the direction it's facing, so it's going through X. So here, we need to make sure that we also, if we reverse the letters, we need to also reverse the direction of the ray above it, and that's important, okay? One thing also, if you think back to line for a second here, if we had a third point above here, you could also see that a line actually consists of two rays that are extending in opposite directions. Like let's just say I had a third point here. Like let's say this is I don't know, point R. You'd have ray RX and ray RV, and that would create the line VX, which we'll get to in one of the worksheets. So you can also think of a line as being basically the combination of two rays extending in opposite directions. Okay, collinear points. We already kind of alluded to it. Just points that are all on the same line. Points along the same line. And an example of that would be something like this. Like let's say we had, oh, I don't know, we'll go with K, B, and S. So these 3 points would be considered collinear. And this is an example of like what I just said. If you had two opposite rays, so let's say ray BS and ray BK, that would create line KS. You could also think that there's a bunch of different ways to name this line, like KB, BS, SK, SB. There's a whole bunch of different ways of doing it. Non-collinear points, I'll let you guess what that means. Yep, you guessed it. Points that are not along the same line. Not along the same line. So let's say we had some points here. Well, they're not all on the same line. So R, D, V. So V is not along this line. Therefore, this is not collinear to these two. Pretty straightforward. Okay, that covers the first page. The next part, coplanar points. So we know what collinear means. It means they're on the same line. Coplanar means, as you can probably guess, it means points that are on the same plane. So points on the same plane. Excuse me. So if I draw a plane, let's try to make it a little better this time. Right, that's slightly better. So we have some points here. Call that O, A, and P. These 3 points would be considered coplanar because they're on, let's call this plane R again. So it's on plane R. And again, you know, think you could name this plane via the 3 points as well. So you could call it plane PAO since these are non-collinear. Okay. Non-coplanar, yep, you guessed it. Points that are not along the same plane. Okay. I apologize for the sound quality. When I did a test video, I know it was a little choppy, so I'm going to try to bring in a different mic tomorrow when I start using this a little better. And, you know, let's make another plane here. So we'll have a point here. We'll do the same 3, I guess. We'll create the exact same one. So O, A, and P. We can call that plane R if we want. Now we're going to have this kind of point over here that's not non-coplanar. So V would be considered non-coplanar. Non-coplanar to the others. Okay. All right, intersection of lines. Well, if 2 lines intersect, what do they intersect along? They intersect at, let's see. Oh, I totally screwed up already. Look at that, guys. This should be the diagram. This is going to be over here when you draw it. Oh, well. So we're going to have, we'll call this line VX. And this will be RL. So line RL. They intersect at this point right here. Okay, we're going to call that B. Intersect at point B. So that'd be a diagram. So I jumped the gun a little bit there. This should actually be going over here. Lines intersect at a point. A single point, by the way. They can only intersect at one point. If lines are intersecting along more than one point, that means it's actually the same line. Like let's say you had one line on top of the other line. Well, technically they're the same line, so they're not really intersecting. But 2 different lines that do intersect at a single point. Okay. Intersection of planes. I'm going to try to draw this. Yeah, we'll see how it goes. Okay, so planes intersect along a line. So we'll see how this looks. This can be a little tricky. So let's say I draw this poor. Oh my God, that's a terrible parallelogram. I apologize. And we're going to go through it. Okay. Let's just show that it's dotted. It's going to cut through that part right there. So it's like chopping through. Think of it having like 2 pieces of paper, right? And they're going through each other. It's going to intersect along a line. Okay? If you have 2 pieces of paper or 2 pieces of cardboard, you fold them together to create a box, it forms a line, right? That's the line. That would be the intersection of the 2 planes, okay? And technically planes extend infinitely in those directions, those flat surfaces. So it's going to create a line, not a line segment. We just can't draw this thing extending forever. So, yeah. Much easier to see that in person. So when I see you guys, the next time I see you, I can show you graphically. It's a little more difficult to see it on a piece of paper. So that's about it, guys. So with this notation, the notes that we've given you, you should be able to work your way through the worksheets I put on the Google Classroom. I'm going to do a few examples, and then the next video I'm going to show you guys how to use a PDF modifier. And in that, I'll show you how to do 1 or 2 of the problems in the worksheets. And if you still have questions, just let me know. And I'll see you guys tomorrow in the digital learning as well. So, thanks.